Hey YouTube, here we are in my dining room, and today I'm going to show you how to make a cheap and simple battery operated contact sensor using Arduino and my sensors. In my case, I'm using it for a chair occupancy detection, which I'll get into in just a second, but you could take this same application and use it to monitor your doors and windows or pretty much any switch that has an open and closed state. Alright, so why did I make a chair occupancy sensor? You're probably asking yourself, this guy is crazy. Well, I like to, one of my goals is to automate every room in my house so the lights turn on and off, automate my lights. So early on I was able to get my lights in my dining room to turn on. I've got a Z-Wave switch here, motion sensor there. These are actually all throughout my house. And it just turns on the switch, lights turn on when it's dark out. So all that's simply controlled through my Vera. However, the tricky part is, when we're sitting down to eat dinner, we're not really moving and re-triggering that sensor. So to make a long story short, I had to try and fake it with timers. So if there's motion within, 3 times within 5 minutes, it sets the timer to longer, maybe a 30-minute timer, which is fine if you're eating. Except if you're not, if you're just walking through 3 times, then the light stays on for a long time. So to solve that, I've made some chair occupancy sensors. So basically, when someone sits down in this chair, it will trigger as that there's someone here, and then the lights don't turn off. So now I can set my timer to much less time and thus save more energy. So let's get into a demo now, and I can show you how this works. Okay, so just a quick demo here. So it's a really basic sensor. All you need is a contact sensor here, so I just have it between the cushion and the chair support. And then when someone sits down, I'll just squeeze it here. It sends that triggered state to the Vera. So I'll just refresh it here, and then you can see that it's tripped. When I get up, it sends that it is no longer tripped. Alright, so it's secure. The other thing, hopefully you can see this, try and bring it up here, is we have a battery status here. So you can see that the battery is 91%. I've had this running for just over 2 months, and these are not alkaline batteries. These are free Harbor Freight batteries, if you recognize those and you're from the US. So these are nickel cadmium or something like that, so they only have maybe 1/3 of the power of a alkaline battery. So this has already lasted 2 months. It's 91%. I'm hoping it's going to last around 200 days, but alkaline batteries should get you close to 3 years in battery life. Okay, so let's talk about building the sensor, what actually goes into it to making a battery-powered sensor that will last this long. First, I'm just going to talk about how you could go about building just a normal contact sensor, and then I'll talk about how I actually built my little chair sensor trigger. Let's talk about the Arduino first. So this is just a standard Pro Mini, but you want to make a couple tweaks to it in order to save as much battery as possible. I'm going to have a link to how I built all this in the video description, so definitely check that out. And in there will be a link to the My Sensors battery build page. So why I'm telling you all this is I chose to desolder my 2 components I'm going to point out here in just a second, but you can also just cut on your Pro Mini, you can cut the traces instead of desoldering. I desoldered mine in case I ever wanted to solder it back on, but ended up totally destroying the LED, so cutting the traces is probably just going to be way easier for you. If you're just going to keep it as a contact sensor, I'd recommend that. But basically what I did was desoldered the regulator here, the voltage regulator. Hopefully you can see where that normally is. And then the LED here, just desoldered that. But like I said, you can cut the traces if you prefer that. Okay, so other than the modifications to the Pro Mini, there's really not much else to it. You've got your standard radio, a battery holder, which are I 3D printed mine, but they're very easy to get. And then lastly, which is optional, but I recommend it, is a 1 ohm resistor. If you don't use that, you'll use an additional 100 microamps of power if you use the internal pull-up resistor, so that's why I recommend using that, but like I said, not required. Alright, so if you just want to use this battery-powered sensor for just a simple door window sensor and you don't want to do my crazy chair sensor, all you need to do is just get a contact sensor like this, normally open contact sensor. So you can easily get these online as well. So it's just two pieces like that. One's a magnet and one's the sensor. So these are a couple examples of what I use around my house if you didn't want to build my chair sensor. But now I'm going to get into how I actually made that. Okay, so here is the sensor that I made, or basically it's just a switch. It's really simple. All I did is took some copper tape and taped it around the metal, this piece of metal here, soldered on some Cat 5 wire, and then when someone sits down, it closes the switch. When they get up, it opens the switch. Really simple. And then I just insulated it with a thin piece of plastic down at the end so it's not constantly touching, and then taped it. So it's really basic. This has been in use for just over 2 months, and it's still working fine, still got plenty of spring left in it. So I'm not exactly sure what type of metal this is. I actually just repurposed it from the roof of my house. This is flashing, so basically just cut some strips and then bent it with a pair of pliers. I ground down the edges because they're pretty sharp when I use my tin snips, just so it didn't pierce the plastic, and then make it so that sensor was constantly closed. But that's it, just basically bend it so it's got a little bend in it, and then makes it springy. Okay, the last thing I want to show you is how this kind of goes between my cushion and the chair support. So I already had I guess a gap between the cushion and the support, so it was pretty perfect. It just enabled me to slide that in there. So hopefully you can see that well enough. It just barely stays open, and then when someone sits in it, it triggers closed. My cat does not trigger it, but my son, who's probably like 40 pounds, 45 pounds, does. So it's pretty good balance between, which is kind of just dumb luck. I didn't really do too much prototyping to get this to work. So you will need some sort of gap between the cushion and the chair. And then I also ended up loosening these screws just slightly, so it will flex a little bit more, so it's not totally clamped down. Hopefully that makes sense. So that's it for the build, at least the hardware. Let's go take a look at the code. You've probably already guessed that I have made the code available via the link in the video description. So check that out to download it. A couple other things to talk about. We are using an additional library here. It is the Arduino VCC library. It was created by Evo, my Sensors Core team member. So big shout out to Evo. Thank you so much for making it. You saved me a lot of time and calculations for this. All right, so to get it, you're going to go to GitHub. If you've never used GitHub before, which you probably have if you're on My Sensors, you can just download the zip file here and add it to your Arduino libraries folder. Okay, going back to the code. The other thing I've done is I have uploaded a custom 1 megahertz bootloader created by Gert Sanders. Big shout out to Gert as well. Thank you for making those. So this is an optional step, but it will save you a little bit more battery because your processor is running 8 times slower, which doesn't really matter for just a simple contact sensor. So I'm not going to get into how to upload a bootloader and all the install steps for that. I've also made a video already for that, so you can check that out. I will show you the bootloader that I've used though. So once you've installed the bootloader, you should see a menu very similar to this one. So you can see the Gert Sanders AVR based boards. So I'm using the Atmega 328P 32 pin, and my CPU frequency is 1 megahertz, and I'm using a D13, that's for the LED. And then I have brownout detection disabled. Okay, so those are my settings I'm using for the custom bootloader. All right, let's go through some of this code here. For the most part, it's pretty much My Sensors standard code, not super complex, but I did want to go through it because there's a couple little intricacies that I've added for this chair occupancy portion. So if you're new to My Sensors or Arduino, you can just uncomment this to define my debug line, and you can see debug messages output to your serial monitor. You'll want to choose your radio type here. And then we have the power level available. I'm using low because my sensors are fairly close to my gateway. Obviously, the lower power level you use for your radio, the less battery you'll use. So set this to the lowest possible you can while still getting good communication. If you change your channel, your My Sensors channel, you can modify that here. And then if you want to manually assign your node ID, you can do it on this line. If you don't want to manually assign it, you want to auto assign, just comment this line out. Okay, the My Transport Wait Ready MS is important because we don't want our battery to drain if the node for some reason can't reach the gateway. So this will basically say, hey, try and reach the gateway for 3 seconds. If you can't reach it, continue on with the code, and then it will sleep. So if for some reason your gateway is down, it will continually try and find it and then drain your battery quickly. So leave this in. I've also found that you don't want to set it anywhere below 3 seconds. Otherwise it won't fully register while it's first booting up. This My baud rate is needed if you want to use a serial monitor with a 1 megahertz node. If you're not using 1 megahertz, you can comment that out and use the standard rate. Okay, here's our include for the VCC library. So go ahead and leave that in if you're using the VCC library, which if you're using my code, you will be. All right, moving on down. We have our child ID if you wanted to modify that. Contact pin, you want to leave that the same, so that is the pin that your contact sensor is plugged into. And then if you want to modify the name, you could do that here. Okay, so I mentioned that there are some, I guess, customizations I've used for my chair occupancy. So basically how this works is I don't want the chair to continually update if maybe someone's shifting in the chair and triggering the interrupt. So I have some delays in there, or some people call it debouncing. So it'll wait actually 3.6 seconds before updating. So I found that's plenty adequate for debouncing and also not turning the lights out on me. So 3.6 seconds is what I have. If you want to adjust that, feel free. I have found some weirdness going below 1,000, so I wouldn't recommend going anywhere below that. But if you want to increase it to 8 seconds or whatever, you could do that here. And I'll show you in the code later where this applies so you can get a better idea of how that works. Next, I have this battery delay in here. So basically, this is a heartbeat. So I have this sensor updating, in my case, every 4 hours. So it'll send the battery value as well as the current state of the sensor, whether it's occupied or not. All right, these are just used, these variables are just used for tracking the debounce and the sleep type. And then down here we have the VCC library variables. So with this sensor, we want to set the VCC min, so basically it'll report 0 battery life left at 1.9 volts. The reason for this is our NRF radio can only go down to 1.9 volts and then it stops working. So we obviously don't want to set this VCC min to 0 and we think that the battery still has some life left in it when it can't communicate. Hopefully that makes sense, but just leave this at 1.9 if you're using the NRF. And then the VCC max, I just have set to 3.3. That is for my 2 AA batteries. And then I just left the VCC correction the same. You can read through the library if you want to tweak that, but mine seemed to be working pretty good, so I just left it. Another thing to note about battery operated sensors, this VCC library will only work if you're using 3.3 volt sensors. If you're using a step-up converter with 5 volt sensors, then you're going to need to check out the My Sensors battery page and use other options for reading the batteries. But if you're making a context sensor like I am here, it is perfect for this use case. Okay, moving on down, all this standard My Sensors stuff, so I'm not going to cover that. Okay, down here, we are disabling our unused pins to save a little more power. If you're interested in how that works, check out this link to Nick Gammon's site to find out more information. All right, if you are using a external resistor, so if you remember, I'm using the 1 ohm resistor. If you're using that, you're gonna keep this line as is. But if you want to use the internal pull-up resistor, you're gonna uncomment this line and then comment this line out. Okay, moving on down, we send the battery level when the node first powers up, just so we can get an idea of how much battery we have when it first starts up. All right, moving into the loop. So the first part of the loop checks to see how we woke up. So my sensors will send back a -1 if it woke by the timer. So there's a timer interrupt, which would be our 4-hour sleep. So if it woke by the timer, it's going to send us a -1. So we're going to perform a different set of functions here. And as I already described up above, basically we're going to send our battery level and the state back to our gateway. So all that code is here. Here it's finding the battery level, and then it is sending it, and then it's also sending the contact value, and then it's going to go back to sleep for another 4 hours, or whatever you decide to set battery delay to. All right, so if we woke by interrupt, so basically we're going to go into our else statement of this wake value. So scroll down here. Okay, so first we're going to check our contact tracker. So this is how we're going to check basically the debounce. So if our contact tracker is less than 2, we're going to go through and read the value. Okay, so it's going to write that value into this array, contact val. It's going to read the value, or write the value of our contact pin. Okay, then it's going to increment contact tracker and sleep for our debounce delay. So then it's going to wake up again, and then it's going to read contact tracker again, because it would be still less than 2, and it's going to write that into the second item of our array, second value of our array. Okay, once it's done that, it's going to move into this else statement. It's going to reset our contact tracker for next time. And it's going to read the value one more time. So for a total of 3 reads for our debounce. And then it's going to compare all 3 of those. So if they're equal, then it's going to go back and see if it needs to send the value. Okay, so it's going to compare the old value to the new value. And if they're different, it's going to send it back to our gateway, which it's doing right here. After it sent that, or even if it didn't need to send it at all, once the interrupt's done, it's going to go back to sleep here. So that's it. If you need a battery-powered sensor, hopefully this helped you. Thanks for watching, everyone.